Hi guys, we're going to start day 2 notes right now. You did day 1 notes in class, so this is your homework, okay? Today we're going to be talking about linear equations in 2 variables. So okay, again, it's a longer note packet because I just want to show you lots of examples, okay? Um, so, yeah. Linear equations are basically, especially linear equations in 2 variables, let's just go ahead and get started, are equations that have 2 variables, obviously. Those variables are going to be x and y, and we use them to graph a line. Okay, so we're not going to get into graphing lines yet. We're just going to get familiar with these kind of equations. Okay, now because it has 2 variables, our solutions are going to consist of 2 numbers as well. Solutions to these kind of equations are ordered pairs, and these ordered pairs, when you plug them in for the x and y in the equation, make the whole statement true. Okay? Now, because we're talking about a line that goes on forever, and that's made up of ordered pairs, there are infinite number of solutions. So we're not going to be able to list them all. That's why we graph the line instead. Okay? But again, we're going to hold off on graphing until later. So let's go ahead and jump into example 1. We need to find 4 solutions to the equation y equals 5x plus 2. So this is a linear equation. Okay? We're going to find 4 solutions, and then we're going to write them in a table. Alright, so we're basically looking for ordered pairs at work. Now, what's really nice about linear equations, which is all you guys are focusing on, is that you get to pick the value you plug into this. So remember, x is representing our input values, y is representing our output values. Okay? So we pick the values we plug in, and that's going to tell us what comes out for the y. So we get to pick our x values, and then the equation will tell us what the y value is. Okay? So it doesn't matter what you pick. I picked 4 numbers, so let's go ahead and just work with my 4 numbers. On your try on your own, you can go ahead and pick whatever numbers you want. My rule of thumb for it is try to pick numbers that are smaller and more easier to work with. No need to stress yourself out with picking 427. Okay? That's just asking for an arithmetic mistake to happen. So I actually ended up picking 0, 1, -1, and 2. Okay, so those are my 4 x's that I picked. All I need to do is find the y's for it. So I'm actually going to go ahead and start out by filling in my table with the x's. I picked -1, 0, 1, and 2. Okay, so let's start with the -1. I go ahead and take that -1 and I plug it in for x into this equation. So now I have y equals 5 times -1 plus 2. And then I just go ahead and simplify. 5 times -1 is -5. -5 plus 2 gives me -3. So my ordered pair comes out to be -1, -3, because that was the x value I picked. That's the y value that got matched with it. Okay. Next number I did was the 0 for x, so I plug that in. Y equals 5 times 0 plus 2. 5 times 0 is 0. So it ended up coming out as y equals 2. Okay. Coughing, 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 coughing. Next one is 1, so I plug that in for the x, so I have 5 times 1, which is 5, plus 2 gives me 7, so the y value is 7. And the last one was 2, so I plug it in. 5 times 2 gives me 10, plus 2 gives me 12 for the y. So now I just go ahead and write those y values that I get right across from the x values that made them. Okay? So, and then this will also give me my ordered pairs. -1, -3, 0, 2, 1, 7, and 2, 12. Now that's very helpful because the next one asks you to list your solutions. Your solutions are the ordered pairs, so we have to list them. Now, when you write them as a list, you need to put them in a set. So with braces, there are these little curly parentheses. Okay? So curly parentheses to start, and then write your ordered pairs. and then a curly parenthesis to end. These do not have to be perfect. I don't expect mine aren't perfect. Just go ahead and try your best with it. As long as it doesn't look like a parenthesis. So it should not look like a parenthesis. Okay? So you guys are going to try this one on your own. You have the equation y equals negative 2 plus 7. Negative 2x plus 7. Okay? You have to do the exact same thing. Find 4 solutions. Write them as a table, and then list your solutions. Okay? Now, we're going to try another one like this. This one, however, has a coefficient that's a fraction. So, you can still pick whatever x's you want. However, it's going to make your life a whole lot easier to choose x values that are multiples of the denominator here, because then the fraction cancels out. Okay, so what I actually decided to pick was a positive 3, because 1/3 of 3 is 1, so it works out really nicely. I picked 0 again, because anything times 0 is still 0. I picked negative 3, because 1/3 of negative 3 is negative 1, and I picked 6, because 1/3 of 6 is 2. So those are the x values I chose. So I'm going to start and fill out my table with that. Again, you guys could pick different values. It's totally fine. You could pick non-multiples of the denominator. You're just going to have fractions for your y's then. Okay? So let's go ahead and start with x is 3. So I plug that in. So I'm doing 1/3 times 3, which is positive 1. So I have 1 minus 1 gives me the y is 0. Okay? Do the same thing with the next value, 0 for x. Plug that in. 1/3 times 0 is 0. 0 minus 1 is negative 1. Next one is negative 3. So that's my x value. Plug it in. 1/3 times negative 3 is negative 1. Negative 1 minus 1 is negative 2. The last one I chose to do is 6. Plug that in. 1/3 times 6 is 2. 2 minus 1 is positive 1. So these y values that I got, 0, negative 1, negative 2, and 1, I'm going to match them with their x values that I used to get them. Okay? And those create my ordered pairs. So to list solutions, I start off with the set, the brace, and then I write the ordered pairs. Okay? Coughing. Alright. Some more vocab. Independent variable is the input value of a function. So that's the x value. It's also the one that's going to happen no matter what. So time is sometimes an independent variable because time does not change. It's not dependent on anything. It's going to keep happening at the same rate all the time. There's lots of other examples of independent variables. So when we come across one, I'll explain it. Dependent variables are the output values of a function, your y values, and they're the ones that actually you're going to get because what am I trying to say? They solely depend on what the input value was. Okay? So whatever you put into it really makes difference on what you get out. Okay? That's why they're called dependent, because they depend on what the independent variable is. Domain is the set of all the x values that's in the relation. Okay? So all the x values used in all those ordered pairs. The range is all the y values that were used. Okay? Again, if I'm going really fast, I probably am, because it hurts to talk. So I'm just trying to get it done. Just pause the video, okay? And take a minute to write it down. It's a lot of vocabulary. Alright, so you will need to be able to recognize the domain and range from many different forms. Coughing. These forms are mapping diagrams. So those were the bubbles that you saw. They were the bubbles that you saw from the notes we did in class. Ordered pairs, which you guys see all the time. A table, which you guys are pretty used to. And a graph. Okay? So these could be points on a graph. All right? The domain of a mapping diagram is basically all the numbers in that first bubble. And those are the numbers where the arrows start. Okay? So all those numbers in that first bubble, you just list them out and that's your domain. The range are all the numbers in the second bubble where the arrows end. Okay? With ordered pairs, domain is made up of the first numbers of each ordered pair. The range is made up of the second numbers for each ordered pair. The table, so it's going to depend on what kind of table we're talking about. If this is a real world example, the table, the domain is going to be made up of the independent variables from a table, the y, or the, which those are your x values. Okay, so sometimes it's labeled with x and y, sometimes it's labeled with real world units. The range is the dependent variable. Okay, now from a graph, so they're just points. The domain is the x-coordinates of those ordered pairs, those points, and the range are the y-coordinates. Okay? Just a reminder, a function is a relation where every x is matched with only one y. Okay? So let's look at some examples. So I'll do one, you do one. I'll do one, you do one. So here's an example of a mapping diagram. Okay? It's asking for the domain, range, and it's a function. So the domain are the x values, and that's in the first bubble. So here are all your x values. We write it out, and when we list the domain, we still use braces. Okay? So I just put a brace, 0, 1, 2, 3, close the braces. Your range is all the numbers in the second bubble. So right here is -1. So that's all I put in the brace, -1. Okay? Is it a function? Coughing. Well, each one of these x values is only going to one number. They just happen to all be the same, like it all happens, go to the same place. So each x is only matched with one y. So yes, it is a function. Okay, so you're going to try this one on your own. All right, example 4. It's just a bunch of ordered pairs. So we're looking for the domain, which are the x values. So -1, 0, 1, and 2. We write it out in braces. The range are the y values, so 4, 5, 6, and -7. Write them in braces. Each x value is only matched with one number. Okay? So because of that, yes, it is a function. So you got 2 to try on your own. Okay? Here's my little hint. No repeats in your domain and range. Okay? So if you have a number that repeats more than once, just write it once in your domain. Just write it once in your range. You don't have to write it 4 or 5 times or how many times it shows up. Okay? Number 5, here we also have to identify the independent and dependent variable, which I totally forgot to do. Oh, well, I did the easy one. X and Y was located already there, so X was our independent and dependent was our Y. Let's go ahead and do yours too. So for the try on your own, we have time and distance. Well, how far you go depends on like how long you're running. So distance depends on time. So that means distance is your dependent. I'm just going to write dis. And time is your independent. Because time is going to move. I mean, we don't stop time because you decide to go slow. We don't speed up time because you decide to go fast. Time is not dependent on how far you go. It's the other way around. So we did that together. Now backtracking to example 5. Domain are all the x values. So I just write those, all of them down, -3, -2, -1, 0, 1, 2, and 3. The range of the y values, but if you notice the y values repeat here, we got 3 listed twice. And it's okay if y values repeat, it's only the x values can't repeat. So 3 is listed twice, we only need to write it once. So the different numbers are 0, 1, 2, and 3. That's our range. Those are the y values that are used. When they ask for domain range, they're not asking how many times they're used, just asking what is used. And as we said, it was okay for the y values to repeat. The x's can't repeat. They can't go to two different numbers, and we don't have that. So because of that, it is a function. Okay? Almost done. I know this is a long one. In example 6, we have to identify the independent and dependent players, or variables. So in our example, Peter coaches soccer clinics and charges $15 per person. T stands for the total amount of money he makes, and P stands for the number of players that sign up. Identify the independent and dependent variable. Well, what's coughing? Which variable depends on the other? Does money depend on how many players sign up? Or does how many players sign up depend on how much money he gets? Well, actually, the money, I totally messed this up when I wrote it out. How much money he gets depends on how many people sign up. So the money depends on how many players. Okay? Be careful of how this is written out. Alright? But that's your last try on your own. If you have any questions, write it down. If you miss stuff, go back, rewind, pause, all that fun stuff. But it's your homework, so you guys have a good weekend, or you already had a good weekend and you're doing this Monday night. Which is very possible, I know. But I will see you next class. Okay? Oh, gosh. And let's go ahead and make that small, and we will stop the video. Bye, guys.